All right, so let's try some examples where we're just given the points. So for number 19, we have two coordinates here. So remember that we just want to label um, the x1 and the y1. Oh, excuse me. Sorry, the x1 and the y1, and then we have our x2 and y2. Right. So remember, the ones go with the ones, and the twos go with the twos. Right. So make sure you keep that straight. So then I just need to remember my formula, which is y2 minus y1 all over x2 minus x1. Okay. So remember, that's just rise over run. And here's the part that's a little tricky, is that the y's go on top, right? So it's a little bit backwards because x's come first in our coordinate pair, but they go on the bottom, right? And y's come second, but they go on top. So that's one thing to keep straight. A lot of times, I would say that's the number one mistake, besides maybe sign errors, is people putting x's on top instead of y's. So remember, it's rise, the vertical, which are the y's, over the run, which is the horizontal, and of course, which is the x's. Okay. So once you get that straight, it's just some addition, subtraction, and then a little bit of reducing fractions, right? So on top, I'm going to do y2, 9, minus y1, which is 4. And then on bottom, I'm going to do x2, which is 5, minus x1, which is negative 2. So notice how I have a negative, right? And you can put parentheses there. You don't necessarily have to every time. You can, just as long as you know when you have a negative, it turns into a positive. So 9 minus 4 is 5, and 5 plus 2 is 7, and that's it. So positive 5 over 7, so that's our slope. Okay, that's all it is. Let's check out the second one. So here we have x1, x2, and y1, y2. So you don't have to necessarily write the labels there every time, but you know, for the video, of course, I want to make sure everybody's really clear on where I'm getting these values. And if it helps you, definitely do it. And you might want to do it to begin with, you know, when you're getting used to this concept. And then, you know, as you figure it out, hopefully it'll become second nature. So y2 goes on top. So y2 minus y1, right? So y2 minus y1, that goes on top, all over x2 minus x1. So remember, there's a built-in negative in these formulas, right? And so that's why we have these double negatives going on, because these negatives are built in, but then these negatives come with the values that were given, right? They came with the x1 and the y1. Okay. All right. So negative turns into a positive in both those situations, and so on top we have 1 plus 3, which is 4. On the bottom we have negative 5 plus 2, which is negative 3, right? And you can write that like that, or you can write it like this. Okay, so negative 4/3, and that's our final answer there. All right, so pretty straightforward. Let's see some more. So here we have some fractions. Don't be scared, right? It's okay. Same idea. So we're gonna do. Let's try it without the labels this time. So I'm going to call these my 1s and these my 2s, okay? So I'm going to start with y2, so 1/2, minus y1, which is 2. Then on the bottom, x2, which is negative 1, minus x1, which is 1/2. Okay, and so on top we have negative 1/2 minus 2, right? So I can do some, just kind of some mental work here real quickly. So 2 is 2 over 1, and I can get a common denominator real easily with just multiplying 2 on top and bottom, right? So that turns into 4/2, right? And so I can think of this as 1/2 minus 4/2. All right, similar thing on the bottom, negative 1 over 1. Oops. And to get a common denominator, I can multiply by 2 on top and bottom to match up with that denominator. And so I end up with negative 2 over 2. So I have negative 2 over 2 minus 1 over 2. Okay, and so as I work that out, negative a half minus 4 halves is negative 3 halves on top. And then on the bottom, negative 2 halves minus 1 half is negative 3 halves. So what's anything divided by itself? That's right, it's 1, right? And if you had to, and another thing is we have a negative divided by a negative, right? So that's going to be a positive. And another thing to think about too is, let's say that these weren't exactly the same, right? That makes it easy because it's just 1. But if they weren't exactly the same, remember the way you divide fractions like this is you take the numerator fraction and multiply by the reciprocal of the denominator fraction. Okay, so it's, the numerator fraction we keep, change, flip, right? Is I think how I've heard a lot of you learned it, and I like that. So keep, change, flip. Okay, so anyway, this would come out to negative 3 times negative 2, which is positive 6. On the bottom, 2 times 3 is 6, which is 1, right? You probably didn't need that, but just a reminder in case that comes up. All right, and then 27. So y2, 9, minus y1, 3, all over x2, which is 2, minus x1, which is 2. All right, so 9 minus 3 on top is 6. 2 minus 2 is 0. And so we have 6 divided by 0, which equals what? Can't divide by 0, right? So when that happens, we know that's undefined, right? So that's what we just say is we have an undefined slope. So m, not necessarily equals undefined because it's not a value, but m is undefined, okay? And I'm okay with you abbreviating and just put UND for the slope. But yeah, so the slope is undefined. Now, let's just think about real quickly what this would look like on a graph. So if I have a graph and I'm plotting these 2 points, so I have 2, 3. I should have done a better job with my graph because 2, 9 is going to go way off the chart. But 2, 3 is right here, and then 2, 9 is going to be in the same spot on the x-axis, right? So it's going to be somewhere up here where 9 is. Let's pretend like that's 9. So what kind of line is that? It's a vertical line. So vertical lines have undefined slopes, right? And it's when you're looking at a coordinate pair, how could we have identified that right off the bat? And you're right, yeah, it's because we have the x values are the same, right? So it's not going to be going left to right. It's just going to be going up and down, right? So, all right, so that's what an undefined slope looks like. All right. So last couple examples here. So we have 29 and 31. So I forgot to write this on the last slide, but our slope formula is y2 minus y1 all over x2 minus x1. Okay. So for 29, y2 is negative 5, right? Minus y1, which is also negative 5. Kind of, so looks like a special case maybe. All right, then on the bottom we'll do x2, which is 9, minus x1, which is negative 2. Okay, so we have a negative negative turns into a positive in both those cases. So negative 5 plus 5 is 0, and 9 plus 2 is 11. So this time we have 0 divided by 11. Is that undefined? You're right, it's not undefined. That's just 0, right? We can do 0 divided by anything. It's always 0. So we just can't divide by 0. So in this case, our slope is 0. And so let's just explore that just for a second on a graph. If I have a graph, and in this case, our y coordinates are the same. They're both at negative 5, right? So what's going to happen is I have negative 2, negative 5, which is right here. And then I have 9, negative 5, which is right here. And so if we connect those dots, what kind of line do we have? Yeah, mine isn't perfect, right? But we can see we have a horizontal line, okay? So when our slope is 0, that makes a horizontal line. And if we're looking at the coordinate points, the way we can easily identify that is if the y coordinates are the same. That means it's not going to go up or down, it's just going to go left and right. Okay, and that makes a horizontal line. All right, so the last one here, we have some decimals. No big deal, same idea, right? Slope is y2 negative 0.3 minus y1, which is 0.9, all over x2 negative 0.1 minus x1, which is 0.3. Okay, so just do the math. Negative 0.3 minus 0.9, 0.3 plus 0.9 is 0.12, but keep the same sign, right? So it'll be, or excuse me, not 0.12, 1.2. Sorry about that. And you can use your calculator if you need to, but 3 plus 9 is 12, right? But when we line up the decimals, we get a 2, we have to carry the 1 into the 1's place. And then negative 0.1 minus 0.3, that's going to be negative 0.4, 0.4. Okay, and we can divide this on our calculator, but 12 divided by 4 is 3, right? So 1.2 divided by 0.4 is going to be 3. And then negative divided by negative makes a positive. So there we go. Right, you can also do long division if you don't have a calculator. And then remember, just real quickly, so when you're doing this, what you would do is you want to get this to be a regular 4, make sure the decimal's on the right side of the number there. So then whatever you do here, make sure you do the same thing here. So we also move this over. So essentially it turns into 4. How many times does 4 go into 12, or 12 divided by 4, right? Which of course we know is 3. All right. So thanks for watching. I know you had to. It's an assignment, but I appreciate you spending the time and putting in the work and taking the notes. And shoot questions my way via email or Google Voice text, and bring those questions to class too if you have them. Okay.